Hello viewers, welcome to my channel, Second Math Hub, the solution to your math problems. We are still on track, but for today we are going to find the trigonometric ratio of a given angle. So there's our first question. Now, if theta is located within the first quadrant and the ratio of tan theta is 3/4, we have to find A, sin theta, B, cos theta, and then C, sin theta plus cos theta. So before we even start solving, let's quickly revise ourselves with the quadrants. So what do you mean by the first quadrant, second quadrant, third quadrant, and then the fourth quadrant? So in trig, the Cartesian plane also known as the xy plane has been divided into 4 equal regions. So here represents our y-axis, then here represents our x-axis. You see that it has been divided into 4 equal regions. Now, in trig, positive angles are measured in the anti-clockwise direction, starting from the positive x-axis. So starting with the positive x-axis, we have to move in the anti-clockwise direction. So the starting point here will be 0 degrees. So from this point to this point, it means that we have covered 90 degrees. From here to this point, that will make 180 degrees. From the starting point to this point, we will cover 270 degrees. And then finally back to our starting point. That should give us 360 degrees. Now, because this was our first region, this region here refers to our first quadrant, our second region. So this will be our second quadrant, our third quadrant, and then our fourth quadrant. So all angles within this region are said to be in the first quadrant. And there is something special about the first quadrant. That is, for the first quadrant, all the trig ratios, the sine, cos, and then the tangent, they are all positive. So take note, this region here is called the first quadrant, and then the ranges of angles within the first quadrant is from 0 degrees to 90 degrees. So any angle that measures from 0 degrees to 90 degrees is said to be in the first quadrant. And again, in the first quadrant, all the trig ratios are positive. The sine, cos, and the tangent, they are all positive. And for now, we are focusing on core maths. So core maths, most of the questions are directed to the first quadrant. So for now, anytime you hear about the first quadrant, you should know where we are talking about. We are talking about this region here. So now back to our question. You see that we've been given the ratio for the tangent of the angle. So there is a particular angle within the first region. When you take its tangent, it should give you 3/4. So using this information, how then do we also find the ratio for sin theta, cos theta, and then sin theta plus cos theta? So quickly, let's draw our right angle triangle. So we have our right angle triangle. So now this side or this angle here will measure 90 degrees. And let's put our acute angle here, theta, at this point. So this is our theta. So now, using this right angle triangle, from SOHCAHTOA. Which of them relates to tan theta? So obviously that is TOA. And what does TOA says? TOA says that when you take the tangent of the acute angle, this should be equal to the length of the opposite divided by the length of the adjacent. The length of the opposite divided by the length of the adjacent. So meaning that from this trig ratio, tan theta is equal to 3/4. 3 here represent the opposite, and then 4 here represent the adjacent, because that is what TOA says. TOA says that the tan of the acute angle must be equal to the length of the opposite divided by the length of the adjacent. So again, from this right angle triangle, let's identify the size of this right angle triangle. Because here is 90 degrees, this side here should be the hypotenuse. This side here should be our opposite, because this side faces the acute angle, and then finally the remaining side becomes the adjacent. So where do we place the 3 and then the 4? Around the right angle triangle. So the 3 should be placed at the opposite side. So meaning that the length of this opposite, the length of this opposite measures 3 units, and then 4 here is for the adjacent. So the length of this adjacent represents 4 units. So that is what we have done. So with this, we also need to calculate the length of the hypotenuse. So before we do that, let's name our right angle triangle. So we are naming it as triangle ABC. Triangle ABC. So now from triangle ABC, we know the length of 2 sides. We know the length of the opposite. We know the length of the adjacent. So can we calculate the length of the hypotenuse? Yes, we can do that using Pythagoras theorem. So from Pythagoras theorem, we know that the length of the hypotenuse, so I'm calling the length of the hypotenuse as line CB. So the length of the hypotenuse squared is equal to the sum of the squares of the other 2 sides. So what is the length of the opposite here? 3. So 3 squared plus, what is the length of the adjacent here? 4. So 4 squared. So we have CB squared is equal to 3 squared is 9, and then 4 squared is 16. CB squared is equal to, we know that 9 plus 16 is 25. We are looking for CB, not CB squared. So we can take the square root on both sides. So the square root and the square will cancel out, leaving CB is equal to square root of 25. That should give us 5 units. So meaning that the length of the hypotenuse measures 5 units. So we are almost done. So now we know the length of each of the sides of our right angle triangle. So with this, we should be able to calculate A sine theta, the sine of this angle. So from SOHCAHTOA, which of them relates to sine? So that is so. And then so says that the sine of the acute angle here, the acute angle is theta, is equal to the length of the opposite. So here the length of the opposite is 3 divided by the length of the hypotenuse. And what is the length of the hypotenuse? 5. So we are done with the A part. Sine theta is equal to 3 on 5. We can also do same for B cos theta. Now from SOHCAHTOA, which of them relates to cos? So that is K. Now what does K says? K says that the cos of the acute angle here should be equal to the length of the adjacent. So here the length of the adjacent measures 4 units divided by the length of the hypotenuse, which is 5. So we are done with the B. Now finally to the C. Finally C. We have to find sin theta plus cos theta, and then we have already done that, so just do the substitution. Sin theta we had 3/5 plus cos theta we had 4/5. So this should give us the denominators are the same, so they are like fractions. So I'll just write 1 and then 7/5, or we can equally change it to mixed fraction. So 5 goes into 7, 1, leaving a remainder of 2/5. So this brings us to the end of today's episode. I hope you enjoyed the lesson. See you next time.